Question 1. Strategic planning requires a comprehensive approach to integrating security and compliance into the development of VMware Spring applications, particularly when handling sensitive data. Which of the following strategies best aligns with regulatory expectations and professional best practices for ensuring application security and compliance throughout the development lifecycle? Option A. Rely solely on the default security configurations provided by the VMware Spring framework, assuming they meet all necessary regulatory requirements without further assessment. Option B. Prioritize the rapid delivery of new features, addressing any identified security vulnerabilities or compliance gaps only if they become critical issues. Option C. Proactively embed security and compliance requirements into the design and development phases, conducting regular reviews and testing to ensure adherence to relevant regulations and best practices. Option D. Defer all security and compliance reviews until the final stages of the development process to avoid delaying feature releases. The correct answer is C. Proactively embed security and compliance requirements into the design and development phases, conducting regular reviews and testing to ensure adherence to relevant regulations and best practices. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise software development where technical decisions must align with business objectives and regulatory compliance. The challenge lies in balancing the desire for rapid feature delivery with the imperative to maintain a secure and compliant system, especially when dealing with sensitive data. The pressure to innovate quickly can sometimes lead to overlooking critical security and compliance requirements, creating significant risks. Correct approach analysis. The correct approach emphasizes a proactive and integrated strategy for security and compliance within the Spring development lifecycle. This aligns with best practices in modern software development, often referred to as shift-left security. By embedding security and compliance considerations from the initial design and development phases, organizations can prevent vulnerabilities and compliance gaps from arising, which is far more cost-effective and less risky than addressing them post-deployment. This approach ensures that the application not only meets functional requirements, but also adheres to relevant data protection regulations and industry standards, thereby safeguarding sensitive information and maintaining stakeholder trust. Incorrect approaches analysis. One incorrect approach involves deferring security and compliance reviews until the end of the development cycle. This is a significant regulatory and ethical failure because it creates a high probability of discovering critical issues late in the process, leading to costly rework, project delays, and potential breaches of data privacy regulations. It demonstrates a lack of due diligence and a disregard for the principle of building secure systems by design. Another incorrect approach is to prioritize feature delivery over addressing identified security vulnerabilities or compliance gaps. This is ethically unsound and legally risky. It directly contravenes the responsibility to protect user data and comply with laws governing data handling. Such a decision can lead to severe penalties, reputational damage, and loss of customer confidence, as it prioritizes short-term gains over long-term security and ethical obligations. Third incorrect approach is to assume that standard Spring security configurations are sufficient without a thorough assessment of specific application needs and regulatory requirements. This is a failure of due diligence. Regulatory frameworks often mandate specific security controls and data handling procedures that may go beyond default configurations. Relying solely on defaults without a tailored assessment can leave the application vulnerable and non-compliant, exposing the organization to legal and financial repercussions. Professional reasoning. Professionals should adopt a risk-based approach, integrating security and compliance into every stage of the development lifecycle. This involves continuous assessment, threat modeling, and adherence to established security and compliance frameworks relevant to the specific industry and jurisdiction. Decision-making should be guided by a principle of secure by design and by default, ensuring that security and compliance are not afterthoughts but fundamental aspects of the development process. Regular training, clear communication channels between development, security, and legal teams, and a culture that values security and compliance are essential for making sound professional judgments. Question 2. The efficiency study reveals that the continuous integration and continuous deployment (CI/CD) pipeline for a critical VMware Spring application is experiencing significant delays, impacting the frequency of feature releases. The development team is considering several strategies to accelerate this process. Which of the following strategies best aligns with professional development practices for VMware Spring applications and addresses the identified efficiency issue? Option A. Implement a custom script to bypass certain automated testing phases in the CI/CD pipeline, prioritizing faster deployment over comprehensive validation. Option B. Increase the resources allocated to the build servers and deployment agents without analyzing the application's build or deployment configuration. Option C. Manually manage application dependencies and configurations directly on the deployment servers to circumvent the automated build process. Option D. Refactor the Spring Boot application's build process to optimize dependency resolution and artifact packaging, and review CI/CD pipeline configurations for potential bottlenecks in build, test, and deployment stages. The correct answer is D. Refactor the Spring Boot application's build process to optimize dependency resolution and artifact packaging, and review CI/CD pipeline configurations for potential bottlenecks in build, test, and deployment stages. Explanation. The efficiency study reveals a significant bottleneck in the deployment pipeline for new features within a VMware Spring-based application. This scenario is professionally challenging because it directly impacts the business's ability to deliver value to its customers in a timely manner, potentially leading to competitive disadvantage and revenue loss. The development team is under pressure to resolve this issue quickly, but any solution must adhere to established VMware Spring development best practices and the underlying principles of secure and efficient software delivery, as implicitly governed by general professional software engineering standards and the implicit expectations of stakeholders for reliable and maintainable systems. The correct approach involves a systematic analysis of the deployment pipeline, identifying the specific stages causing delays, and implementing targeted optimizations within the VMware Spring application's configuration and build processes. This might include refining dependency management, optimizing build tool configurations, e.g., Maven or Gradle, or improving the efficiency of Spring Boot packaging. This represents best professional practice because it addresses the root cause of the inefficiency without introducing unnecessary complexity or technical debt. It aligns with the professional obligation to deliver robust, maintainable, and performant software, ensuring that the application remains scalable and secure. An incorrect approach would be to bypass or significantly alter established deployment procedures without thorough testing and impact assessment. For instance, attempting to manually inject dependencies or skip critical build steps to speed up deployment would introduce significant risks of runtime errors, security vulnerabilities, and deployment inconsistencies. This violates the professional responsibility to maintain system integrity and reliability. Another incorrect approach would be to implement a quick fix that addresses the symptom but not the underlying cause, such as simply increasing server resources without optimizing the application's deployment process. This is professionally unsound as it leads to recurring issues and inefficient resource utilization, failing to address the core problem identified by the efficiency study. Professionals should employ a structured decision-making process that begins with a clear understanding of the problem statement and its business impact. This involves gathering data, analyzing the current state, identifying potential solutions, evaluating their risks and benefits against established best practices and architectural principles, and then implementing the most appropriate solution with rigorous testing and validation. The focus should always be on sustainable, efficient, and secure solutions that align with the long-term health of the application and the business objectives. Question 3. Consider a scenario where a development team working on a critical enterprise application built with VMware Spring is presented with a new, highly publicized microservices framework that promises significant improvements in developer productivity and application scalability. The team has been using a well-established, albeit older, approach for managing inter-service communication within their Spring Boot applications. The team lead is eager to adopt the new framework to stay current with industry trends and potentially accelerate feature delivery. What is the most professionally responsible course of action? Option A. Immediately integrate the new microservices framework into the core application to leverage its promised productivity gains and scalability benefits without delay. Option B. Reject the new framework outright, as the current communication approach is stable and well understood, and avoid introducing potential risks associated with unproven technologies. Option C. Conduct a thorough evaluation of the new framework, including a proof of concept, to assess its compatibility, performance impact, security implications, and long-term maintainability within the existing Spring application architecture before considering adoption. Option D. Adopt the new framework for a small, non-critical feature as a trial, without a formal evaluation process, to gauge its immediate impact on developer workflow. The correct answer is C. Conduct a thorough evaluation of the new framework, including a proof of concept, to assess its compatibility, performance impact, security implications, and long-term maintainability within the existing Spring application architecture before considering adoption. Explanation. Scenario analysis. This scenario presents a common challenge in professional development where a developer must choose between adopting a new, potentially more efficient technology and adhering to established, well-understood practices. The challenge lies in balancing innovation with stability, risk management, and the long-term maintainability of the application. The pressure to deliver features quickly can tempt developers to take shortcuts or adopt unproven solutions, which can lead to technical debt, security vulnerabilities, or increased operational complexity. Careful judgment is required to assess the true benefits and risks of each approach in the context of the project's goals and constraints. Correct approach analysis. The correct approach involves a thorough evaluation of the new technology's impact on the existing application architecture, security posture, and operational overhead. This includes understanding its integration points, potential performance implications, and the availability of support and documentation. Adopting a new technology without due diligence can introduce unforeseen risks. Best professional practice dictates a phased adoption or a proof of concept to validate its suitability. This aligns with principles of responsible software development, emphasizing stability, security, and maintainability. The VMware Spring framework itself promotes modularity and extensibility, suggesting that new components should be integrated thoughtfully rather than haphazardly. Correct approach is analysis. Adopting the new technology immediately without any evaluation is a failure to perform due diligence. This bypasses critical risk assessment and can lead to introducing vulnerabilities or performance issues that compromise the application's integrity. It ignores the principle of understanding the full implications of a change before implementation, ignoring the new technology entirely and continuing with the older approach, even if it is less efficient or has known limitations, can also be professionally unsound. This represents a failure to innovate and potentially improve the application's performance, security, or developer productivity. It can lead to the application becoming outdated and harder to maintain in the long run, increasing technical debt. Implementing the new technology solely based on its perceived trendiness or a superficial understanding of its benefits, without considering its compatibility with the existing Spring application's specific requirements and constraints, is a significant ethical and professional lapse. This can lead to a poorly integrated solution that is difficult to debug and maintain, ultimately harming the project and its users. Professional reasoning. Professionals should employ a structured decision-making framework when evaluating new technologies. This framework typically involves 1. Defining the problem or opportunity. Clearly understand what the new technology aims to solve or improve. 2. Research and information gathering. Thoroughly investigate the technology, its features, limitations, and community support. 3. Risk assessment. Identify potential technical, security, and operational risks associated with adoption. 4. Impact analysis. Evaluate how the technology will affect the existing application infrastructure and development team. 5. Proof of concept or pilot. If feasible, test the technology in a controlled environment. 6. Decision and justification. Make an informed decision based on the gathered information and clearly document the rationale. 7. Implementation and monitoring. If adopted, implement carefully and monitor performance and stability. Question 4. The investigation demonstrates that a critical security vulnerability has been identified in a production VMware Spring application. The development team has a hotfix ready, but the next scheduled major release is still several weeks away. The team must decide on the most appropriate course of action to mitigate the risk to users and the system. Option A. Proceed with deploying the hotfix to a small subset of production environments first, closely monitoring for any adverse effects before a wider rollout. Option B. Publicly disclose the vulnerability and the existence of a hotfix to inform users of the potential risk. Option C. Delay the deployment of the hotfix until the next scheduled major release to minimize disruption to the release schedule. Option D. Immediately deploy the hotfix to all production environments after a brief internal review to ensure it addresses the vulnerability. The correct answer is D. Immediately deploy the hotfix to all production environments after a brief internal review to ensure it addresses the vulnerability. Explanation. Scenario analysis. This scenario presents a common challenge in software development where a critical security vulnerability is discovered post-deployment. The professional developer must balance the immediate need to protect users and the system with the potential disruption caused by a hotfix. The challenge lies in accurately assessing the risk, determining the appropriate response timeline, and ensuring that the fix itself doesn't introduce new issues, all while adhering to established development and deployment policies. The pressure to act quickly against the need for thoroughness creates a complex decision-making environment. Correct approach analysis. The correct approach involves a structured, risk-based decision-making process. This aligns with best practices in software engineering and security, emphasizing a methodical response to critical issues. The immediate steps of isolating the vulnerability, assessing its impact, and developing a targeted hotfix demonstrate a commitment to user safety and system integrity. The subsequent rigorous testing and phased rollout are crucial for preventing further disruption or the introduction of new defects, which is a core tenet of professional software development and deployment. This approach prioritizes minimizing harm and ensuring stability, reflecting a mature understanding of the software development lifecycle and its associated risks. Incorrect approaches analysis. One incorrect approach involves immediately deploying a fix without adequate testing. This bypasses essential quality assurance steps, increasing the risk of introducing new bugs or performance degradation, which could be as damaging as the original vulnerability. Demonstrates a failure to adhere to professional development standards that mandate thorough testing before production deployment. Another incorrect approach is to delay the fix indefinitely while awaiting a planned major release. This demonstrates a disregard for user security and data protection, potentially exposing the system and its users to significant harm. It violates the ethical obligation to address critical vulnerabilities promptly and responsibly. A third incorrect approach is to communicate the vulnerability publicly before a fix is ready or deployed. This can cause undue panic among users and potentially alert malicious actors to exploit the weakness, exacerbating the security risk. Professional practice dictates responsible disclosure and communication, typically after a solution is in place or imminent. Professional reasoning. Professionals should employ a risk assessment framework. This involves identifying the threat, evaluating its potential impact, and determining the likelihood of exploitation. Based on this assessment, a decision on the urgency and nature of the response can be made. A critical vulnerability demands immediate attention, but the response must be proportionate and controlled. This framework encourages a balanced approach, prioritizing safety and stability while managing resources effectively. It promotes a proactive and responsible stance towards software quality and security. Question 5. Upon reviewing a new feature request for a VMware Spring application that requires integration with a third-party service, a developer identifies a potential solution that deviates from the established microservice communication patterns. The developer is under pressure to deliver the feature within a tight deadline. What is the most professionally responsible course of action? Option A. Thoroughly research existing VMware Spring best practices for integrating external services, consult with the architecture team, and potentially develop a small proof of concept to validate the proposed integration pattern before implementation. Option B. Inform the product owner that the request cannot be fulfilled within the current architectural constraints and suggest a scaled-down version of the feature. Option C. Proceed with the feature implementation using the deviating pattern and document the deviation for future consideration, without seeking immediate architectural guidance. Option D. Immediately implement the proposed solution to meet the deadline, assuming it will be refactored later if issues arise. Correct answer is D. Immediately implement the proposed solution to meet the deadline, assuming it will be refactored later if issues arise. Explanation. This scenario presents a professional challenge due to the inherent tension between delivering a feature quickly and ensuring its long-term maintainability and adherence to established architectural patterns within a VMware Spring environment. The pressure to meet deadlines can often lead to shortcuts that, while seemingly beneficial in the short term, can introduce technical debt, security vulnerabilities, or performance issues down the line. Careful judgment is required to balance immediate business needs with the principles of robust software development. The correct approach represents best professional practice because it prioritizes a thorough understanding of the existing architectural patterns and best practices for VMware Spring development. This involves consulting documentation, engaging with senior developers or architects, and potentially conducting a small proof of concept to validate the proposed solution. This methodical approach ensures that the new feature integrates seamlessly with the existing codebase, adheres to security standards, and is designed for scalability and maintainability. It aligns with professional ethical obligations to deliver high-quality, secure, and reliable software. An incorrect approach that involves immediately implementing the feature without proper architectural review fails to uphold professional standards. This could lead to the introduction of anti-patterns, increased technical debt, and potential security vulnerabilities if not carefully considered within the context of the broader Spring application. Such a shortcut disregards the established principles of software engineering and the specific best practices for the VMware Spring framework, potentially jeopardizing the stability and security of the application. Another incorrect approach, which is to defer the decision to a later date without any immediate action or investigation, is also professionally unacceptable. This inaction can lead to further delays, increased pressure, and a higher likelihood of rushed, suboptimal solutions when the decision can no longer be postponed. It demonstrates a lack of proactive problem-solving and a failure to address potential architectural drift. The professional reasoning process for similar situations should involve a structured decision-making framework. First, clearly define the problem and the desired outcome. Second, identify potential solutions and evaluate them against established architectural principles, best practices, and any relevant regulatory or security guidelines. Third, consult with subject matter experts or senior team members to gain diverse perspectives. Fourth, consider the trade-offs of each approach, including short-term gains versus long-term implications. Finally, document the chosen approach and the rationale behind it to ensure transparency and facilitate future understanding. Question 6. Benchmark analysis indicates that the current VMware Spring application exhibits significant technical debt, including outdated third-party libraries with known vulnerabilities and complex, tightly coupled code modules. The product roadmap prioritizes rapid delivery of new customer-facing features, which approach best balances the need for innovation with the imperative to maintain a secure and sustainable application. Option A. Assign a dedicated, separate team to address all technical debt in isolation from the feature development teams, with no defined timeline for completion. Option B. Immediately halt all new feature development to undertake a comprehensive, large-scale refactoring of the entire application codebase to eliminate all identified technical debt. Option C. Proactively identify and prioritize technical debt based on security risks and business impact, integrating remediation efforts into the regular development sprints alongside new feature development. Option D. Defer all technical debt remediation until after the current feature roadmap is completed, focusing exclusively on delivering new functionalities to meet market demands. The correct answer is C. Proactively identify and prioritize technical debt based on security risks and business impact, integrating remediation efforts into the regular development sprints alongside new feature development. Explanation: this scenario presents a professional challenge related to managing technical debt and its impact on application security and maintainability within a VMware Spring environment. The challenge lies in balancing the immediate need for new feature development against the long-term risks associated with outdated dependencies and unaddressed architectural issues. Careful judgment is required to prioritize remediation efforts without stifling innovation or introducing new vulnerabilities. The correct approach represents best professional practice because it advocates for a structured, risk-based strategy. By performing a thorough assessment of technical debt, prioritizing based on security vulnerabilities and business impact, and integrating remediation into the development lifecycle, the team proactively mitigates risks. This aligns with general principles of secure software development and responsible lifecycle management, ensuring the long-term health and security of the application. An incorrect approach that solely focuses on new feature development without addressing technical debt is professionally unacceptable. This failure to manage technical debt can lead to increased security vulnerabilities, making the application susceptible to exploits. It also hinders future development by making the codebase more complex and difficult to modify, potentially leading to increased bug rates and slower delivery times. From a regulatory perspective, depending on the industry and data handled, such negligence could violate compliance requirements related to data security and system integrity. Another incorrect approach that attempts to address all technical debt simultaneously without prioritization is also professionally unsound. This can lead to resource overallocation, project delays, and a lack of focus on the most critical issues. It can also result in boil-the-ocean scenarios where significant effort is expended with minimal tangible improvement, leading to developer burnout and project stagnation. The professional reasoning framework to use in such situations involves a continuous cycle of assessment, prioritization, and integration. First, conduct a comprehensive audit of the technical landscape, identifying areas of technical debt. Second, evaluate the risks associated with each debt item, considering security implications, performance degradation, and impact on future development. Third, prioritize remediation efforts based on this risk assessment, focusing on high-impact, high-risk items. Fourth, integrate technical debt reduction into the regular development workflow, allocating dedicated time and resources for refactoring and updates. Finally, establish metrics to track progress and continuously reassess the technical debt landscape. Question 7. Examination of the data shows that a new feature is being developed for a critical VMware Spring application. The development team believes the feature is self-contained and will not impact other parts of the system. What is the most appropriate next step to ensure the stability and integrity of the application before deployment? Option A. Perform a quick review of the code by a single senior developer to confirm the self-contained nature of the feature. Option B. Delay the deployment indefinitely until absolute certainty of zero impact can be achieved, regardless of development timelines. Option C. Proceed with deployment immediately, as the development team has confirmed the feature is self-contained and unlikely to cause issues. Option D. Conduct a comprehensive impact assessment involving relevant stakeholders to identify all potential dependencies, risks, and downstream effects, and document mitigation strategies. The correct answer is D. Conduct a comprehensive impact assessment involving relevant stakeholders to identify all potential dependencies, risks, and downstream effects, and document mitigation strategies. Explanation. Scenario analysis. This scenario presents a common challenge in software development, balancing the introduction of new features with the potential for unintended consequences on existing functionality and system stability. The professional challenge lies in conducting a thorough impact assessment without introducing undue delays or stifling innovation. It requires a proactive, risk-aware approach to development, ensuring that changes are understood and managed before deployment. The need for careful judgment stems from the interconnected nature of software components and the potential for even minor changes to have cascading effects. Correct approach analysis. The correct approach involves a systematic and comprehensive impact assessment. This includes identifying all affected components, dependencies, and potential downstream effects. It necessitates collaboration with stakeholders, including QA, operations, and potentially end users, to gather diverse perspectives on potential risks. Documenting the assessment, including identified risks and mitigation strategies, is crucial for transparency and accountability. This approach aligns with best professional practices by prioritizing system integrity, minimizing downtime, and ensuring a smooth user experience. It demonstrates a commitment to quality and risk management, which are fundamental ethical considerations in software engineering. Incorrect approaches analysis. One incorrect approach is to proceed with the deployment without a formal impact assessment, relying solely on developer intuition. This represents a significant regulatory and ethical failure. It disregards the principle of due diligence and the responsibility to ensure the stability and security of the deployed system. Such an approach increases the likelihood of critical bugs, security vulnerabilities, and service disruptions, potentially leading to reputational damage and financial losses for the organization. It also violates the implicit trust placed in developers to deliver reliable software. Another incorrect approach is to conduct a superficial assessment that only considers immediate, obvious impacts. This is also professionally unacceptable, as it fails to identify indirect or emergent risks. It demonstrates a lack of thoroughness and a disregard for the complexity of modern software systems. This can lead to unforeseen issues that are more difficult and costly to resolve post-deployment. Ethically, it falls short of the professional standard of care expected in software development. A third incorrect approach is to delay the deployment indefinitely due to an overly cautious or fear-driven assessment, without defining clear criteria for proceeding or mitigating identified risks. While caution is important, paralysis by analysis is detrimental. This approach can stifle innovation, lead to missed market opportunities, and create internal frustration. Professionally, it fails to balance risk management with the business need for timely delivery. It suggests a lack of confidence in the team's ability to manage and mitigate risks effectively. Professional reasoning. Professionals should adopt a structured decision-making process for impact assessments. This begins with clearly defining the scope of the change. Next, identify all direct and indirect components that might be affected. Engage relevant stakeholders to brainstorm potential risks and dependencies. Prioritize identified risks based on their likelihood and potential severity. Develop mitigation strategies for high-priority risks. Document the entire process, including findings, decisions, and mitigation plans. Finally, establish clear go/no-go criteria for deployment based on the assessment and mitigation effectiveness. This iterative and collaborative process ensures that decisions are informed, risks are managed, and the deployment proceeds with a high degree of confidence. Question 8. Performance analysis shows a significant increase in transaction latency across multiple user-facing features within the VMware Spring application. Users are reporting intermittent slowdowns, but the exact timing and specific features affected vary. What is the most effective initial step to diagnose the root cause of this performance degradation? Option A. Conduct interviews with individual users to gather detailed qualitative feedback on their experience of the slowdowns and ask them to reproduce the issues. Option B. Initiate a comprehensive impact assessment by correlating user-reported issues with system-wide performance metrics, logs, and distributed traces to identify patterns and isolate affected services or infrastructure components. Option C. Immediately roll back the most recent application deployment, assuming it is the cause of the performance degradation, and monitor for improvements. Option D. Focus on optimizing the database queries and caching mechanisms of the most frequently accessed microservices, as these are common performance bottlenecks. The correct answer is B. Initiate a comprehensive impact assessment by correlating user-reported issues with system-wide performance metrics, logs, and distributed traces to identify patterns and isolate affected services or infrastructure components. Explanation. Scenario analysis. This scenario presents a common challenge in software development where performance degradation impacts user experience and potentially business operation. The challenge lies in accurately identifying the root cause of the performance issue within a complex, distributed VMware Spring application. Without a systematic approach, developers might jump to conclusions, implement ineffective fixes, or even introduce new problems, leading to wasted effort and prolonged downtime. The pressure to resolve performance issues quickly, coupled with the interconnectedness of microservices, necessitates a structured impact assessment. Correct approach analysis. The correct approach involves a methodical impact assessment that begins with understanding the scope and severity of the performance degradation. This includes gathering concrete evidence of the slowdown, such as specific transaction times, error rates, and resource utilization metrics from monitoring tools. The next step is to isolate the affected components or services by analyzing logs, traces, and metrics across the application's lifecycle. This systematic isolation allows for targeted investigation, preventing unnecessary changes to unrelated parts of the system. By focusing on observable data and logical dependencies, this approach aligns with best practices for incident response and root cause analysis, ensuring that fixes are effective and do not introduce regressions. This methodical process is crucial for maintaining system stability and meeting service-level objectives, which are often implicitly or explicitly governed by contractual agreements and industry standards for reliability. Incorrect approaches analysis. One incorrect approach is to immediately assume a recent code deployment is the sole cause without empirical evidence. This bypasses the crucial step of broad impact assessment and can lead to premature rollback or hasty code fixes that might not address the actual problem, potentially causing further disruption. This approach fails to adhere to a data-driven decision-making process, which is a cornerstone of professional software engineering and incident management. Another incorrect approach is to focus solely on optimizing individual microservice performance in isolation, without considering their interactions and dependencies. While individual service optimization can be beneficial, performance issues often arise from inter-service communication, data flow, or resource contention across multiple services. This narrow focus ignores the holistic nature of a distributed system and can lead to suboptimal or ineffective solutions. This violates the principle of understanding system-wide behavior, a critical aspect of professional development in complex environments. A third incorrect approach is to rely on anecdotal user reports without correlating them with system metrics. While user feedback is valuable, it needs to be validated and quantified through objective performance data. Acting solely on subjective reports can lead to misdiagnosis and inefficient allocation of resources, as the perceived issue might not accurately reflect the underlying technical problem. This approach lacks the rigor required for professional problem solving and can lead to a reactive rather than proactive resolution. Professional reasoning. Professionals should approach performance issues by first establishing a clear understanding of the problem's scope and impact through data. This involves leveraging observability tools to gather metrics, logs, and traces. The next step is to systematically isolate the affected components by analyzing dependencies and data flow. This data-driven, systematic approach ensures that resources are focused on the most probable causes, leading to efficient and effective resolution. When faced with performance degradation, professionals should ask, what data do we have to quantify the problem? And what are the dependencies and interactions of the affected components? This framework promotes a logical progression from observation to hypothesis to validation, minimizing the risk of incorrect interventions and ensuring adherence to professional standards of care in system management. Question 9. The control framework reveals that a new microservice, developed using VMware Spring Boot, is being integrated into an existing customer-facing application. This microservice will process and store personally identifiable information, PI, that was previously handled by a monolithic component. What is the most appropriate next step to ensure compliance and security? Option A. Rely on the default security configurations provided by the VMware Spring Boot framework, assuming they are sufficient for handling PII without further customization or assessment. Option B. Proceed with the integration, assuming that the existing security measures of the monolithic application will automatically extend to the new microservice due to their shared development environment. Option C. Schedule a security review for the microservice only after it has been successfully deployed and is actively processing live customer data. Option D. Perform a comprehensive impact assessment of the new microservice, focusing on its data handling, access controls, and interaction with existing security policies to identify potential risks before production deployment. The correct answer is D. Perform a comprehensive impact assessment of the new microservice, focusing on its data handling, access controls, and interaction with existing security policies to identify potential risks before production deployment. Explanation. The control framework reveals a potential vulnerability in the application's handling of sensitive user data during the deployment of a new microservice. This scenario is professionally challenging because it requires a proactive assessment of risks before a potential incident occurs, balancing the need for rapid development with robust security and compliance. The challenge lies in accurately predicting the impact of a new component on existing security controls and data privacy regulations, specifically within the context of the VMware Spring ecosystem. The correct approach involves conducting a thorough impact assessment that specifically evaluates how the new microservice interacts with existing data stores, authentication mechanisms, and authorization policies. This assessment must consider the data lifecycle within the Spring application, including data in transit and at rest, and how the new service might introduce new attack vectors or inadvertently expose sensitive information. This aligns with best professional practices by prioritizing a risk-based security strategy, ensuring that development does not outpace security considerations. It directly addresses the principle of security by design and privacy by design, which are fundamental to responsible software development and compliance with data protection regulations. An incorrect approach would be to assume that the new microservice, being developed within the trusted VMware Spring ecosystem, inherently inherits all existing security controls without explicit verification. This overlooks the possibility of misconfigurations, new dependencies introducing vulnerabilities, or the microservice's specific logic creating unintended data exposure points. This failure to perform a specific impact assessment for the new component represents a significant regulatory and ethical lapse, as it increases the likelihood of data breaches and non-compliance with data protection mandates. Another incorrect approach is to defer the security review of the microservice until after it has been deployed into production. This reactive stance is professionally unacceptable because it significantly elevates the risk of a security incident occurring while the vulnerable component is live. It demonstrates a disregard for the principle of minimizing risk and can lead to severe reputational damage, financial penalties, and loss of customer trust, all of which are direct consequences of failing to adhere to due diligence in security and compliance. The professional reasoning process for such situations should involve a structured risk management framework. This begins with identifying potential threats and vulnerabilities introduced by new components. Subsequently, an impact assessment should be performed to understand the potential consequences of these vulnerabilities, considering both technical and regulatory implications. Based on the assessment, appropriate mitigation strategies should be designed and implemented before deployment. Continuous monitoring and periodic reassessment are also crucial to adapt to evolving threats and system changes. Question 10. Analysis of the proposed integration of a new microservice into an existing VMware Spring-based application, which handles sensitive customer data, requires a thorough evaluation of its potential effects. Which of the following approaches best ensures the integrity, security, and compliance of the application and its data? Option A. Proceed with the integration based on the development team's confidence in the new microservice's functionality, performing only basic unit tests. Option B. Perform a quick review of the microservice's code for obvious errors and assume no significant impact on other parts of the application. Option C. Defer the detailed impact assessment until after the microservice has been deployed to production, addressing any issues that arise reactively. Option D. Conduct a comprehensive impact assessment that systematically identifies all affected components, potential risks, functional, security, performance, compliance, and defines mitigation strategies before proceeding with integration. Correct answer is D. Conduct a comprehensive impact assessment that systematically identifies all affected components, potential risks, functional, security, performance, compliance, and defines mitigation strategies before proceeding with integration. Explanation. Scenario analysis. This scenario presents a common challenge in software development, particularly within regulated environments. The core difficulty lies in balancing the need for rapid feature delivery with the imperative to maintain system integrity and compliance. Introducing new functionality, especially one that interacts with sensitive data or core business logic, inherently carries risks. These risks can range from introducing subtle bugs that compromise data accuracy to creating security vulnerabilities or performance degradations. Pressure to innovate and respond to market demands can often conflict with the meticulous processes required for thorough impact assessment, making it a professionally challenging situation that demands careful judgment and adherence to established protocols. Correct approach analysis. The correct approach involves a comprehensive and systematic impact assessment. This process should begin with a clear understanding of the proposed feature scope, its intended functionality, and its potential interactions with existing systems and data. It necessitates identifying all affected components, including databases, APIs, user interfaces, security controls, and operational processes. A thorough assessment would involve analyzing potential risks across various dimensions: functional correctness, performance, security, data integrity, and compliance with relevant regulations. This would then inform the development of mitigation strategies, testing plans, and rollback procedures. This approach represents best professional practice because it aligns with the principles of responsible software engineering and regulatory compliance. By proactively identifying and addressing potential issues, it minimizes the likelihood of adverse outcomes, protects the integrity of the system, and ensures adherence to legal and ethical obligations. In the context of professional development, this systematic approach demonstrates due diligence and a commitment to delivering high-quality, secure, and compliant software. Incorrect approaches analysis. One incorrect approach involves proceeding with the feature's integration without a formal impact assessment, relying solely on developer intuition and ad hoc testing. This is professionally unacceptable because it bypasses critical risk identification and mitigation steps. It creates a high probability of introducing unforeseen defects, security vulnerabilities, or performance issues that could have significant financial, reputational, or regulatory consequences. This approach demonstrates a disregard for established best practices and a failure to uphold professional responsibility. Another incorrect approach is to conduct a superficial assessment that only considers the immediate functional impact, neglecting broader system interactions, security implications, or long-term maintainability. This is also professionally unacceptable as it fails to provide a holistic view of the potential consequences. It leaves the system vulnerable to risks that were not identified or addressed, potentially leading to compliance breaches or operational failures down the line. This approach indicates a lack of thoroughness and a failure to exercise due professional care. Third incorrect approach might involve delaying the impact assessment indefinitely, prioritizing immediate development over risk evaluation. This is professionally unsound as it creates technical debt and increases the likelihood of significant problems arising later when they are more difficult and costly to resolve. It also demonstrates a failure to manage project risks effectively and a potential disregard for the stability and security of the production environment. Professional reasoning. Professionals should approach impact assessment by first establishing a clear understanding of the project's objectives and constraints. They should then adopt a structured methodology that systematically identifies all potential impacts, both direct and indirect. This involves engaging relevant stakeholders, including development, operations, security, and compliance teams. A risk-based approach should be employed, prioritizing the assessment of high-impact and high-probability risks. Documentation of the assessment process, findings, and mitigation strategies is crucial for accountability and future reference. Finally, professionals must be empowered to advocate for sufficient time and resources to conduct thorough assessments, even when faced with pressure for rapid delivery, understanding that proactive risk management is a fundamental aspect of professional responsibility. Question 11. Market research demonstrates a growing demand for real-time personalized financial advice delivered through a new microservice architecture. The development team proposes to integrate a novel machine learning model into this service to generate these recommendations. Before proceeding with development, what is the most professionally responsible approach to ensure the new service and its integrated model meet all regulatory and operational requirements? Option A. Obtain informal feedback from a few senior engineers and product managers regarding the potential impact, and if there are no immediate red flags, proceed with development and integration. Option B. Proceed with development and deploy the new service, relying on post-deployment monitoring to identify and address any issues that arise, assuming the team's expertise will prevent significant problems. Option C. Implement the machine learning model first in a limited, non-production environment, and then integrate it into the microservice, assuming that if it performs well in isolation, it will be safe for production. Option D. Conduct a comprehensive impact assessment that evaluates the proposed microservice and machine learning model against existing systems, data privacy regulations, financial transaction integrity standards, and security protocols, documenting all identified risks and proposed mitigation strategies. The correct answer is D. Conduct a comprehensive impact assessment that evaluates the proposed microservice and machine learning model against existing systems, data privacy regulations, financial transaction integrity standards, and security protocols, documenting all identified risks and proposed mitigation strategies. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid innovation and the need for robust impact assessment within a regulated financial services environment. The pressure to deliver new features quickly can lead to shortcuts in evaluating potential risks, which, if not managed properly, can result in regulatory noncompliance, financial losses, and reputational damage. Careful judgment is required to balance speed with thoroughness. The correct approach represents best professional practice because it prioritizes a structured and documented impact assessment process before deployment. This aligns with the principles of responsible innovation and risk management expected within regulated industries. by systematically identifying potential impacts on existing systems, data integrity, security, and compliance with relevant financial regulations, e.g., those governing data privacy, transaction integrity, and consumer protection. The development team ensures that risks are understood and mitigated proactively. This proactive stance is crucial for maintaining operational stability and adhering to regulatory mandates, thereby safeguarding both the organization and its customers. An incorrect approach that bypasses a formal impact assessment is professionally unacceptable because it introduces significant, unquantified risks. This failure to conduct due diligence can lead to unforeseen system failures, data breaches, or non-compliance with financial regulation, potentially resulting in severe penalties, fines, and loss of customer trust. Another incorrect approach that relies solely on anecdotal evidence or informal discussions to gauge impact is also professionally deficient. This subjective method lacks the rigor required for a comprehensive risk evaluation and can overlook critical dependencies or vulnerabilities. Finally, an approach that defers the impact assessment until after deployment is a clear regulatory and ethical failure. This reactive stance means that any negative impacts will already have occurred, making remediation more costly and potentially leading to breaches of regulatory requirements that mandate proactive risk management and system integrity. The professional decision-making process for similar situations should involve establishing clear impact assessment protocols as an integral part of the development lifecycle. This includes defining criteria for when an assessment is mandatory, the scope of the assessment, and the stakeholders involved. When faced with a new feature or change, professionals should ask, what are the potential consequences of this change on our existing infrastructure, data, security posture, and regulatory obligations? What evidence do we need to gather to confidently answer this question? Who needs to be consulted? What are the acceptable levels of risk, and how will we monitor for them? This systematic, evidence-based approach ensures that decisions are informed, risks are managed, and compliance is maintained. Question 12. The performance metrics show a significant and sudden increase in response times for a critical VMware Spring application, impacting user productivity. The development team has identified a potential code change that might resolve the issue, but they are concerned about the time it will take to conduct a full impact assessment. What is the most professional and compliant course of action? Option A. Proceed with deploying the suspected code fix immediately to production, as the performance issue is critical and delaying the fix could cause further business disruption. Option B. Conduct a rapid, high-level impact assessment focusing only on the immediate application's functionality and deploy the fix if no obvious negative impacts are identified. Option C. Halt all production deployments and initiate a comprehensive impact assessment that considers the application's dependencies, downstream systems, security implications, and potential compliance risks before any code change is considered for deployment. Option D. Roll back the application to a previous stable version and then investigate the performance issue in a separate development environment without performing any impact assessment on the rollback itself. The correct answer is A. Proceed with deploying the suspected code fix immediately to production, as the performance issue is critical and delaying the fix could cause further business disruption. Explanation. This scenario presents a professional challenge because the development team is facing a situation where a critical performance degradation has been identified in a production VMware Spring application. The challenge lies in balancing the urgency of resolving the performance issue with the need to adhere to established change management and impact assessment protocols. A rushed or incomplete impact assessment could lead to unintended consequences, further system instability, or even regulatory noncompliance if the application handles sensitive data or is subject to specific service level agreements, SLAs. Careful judgment is required to ensure that any remediation efforts are both effective and controlled. The correct approach represents best professional practice because it prioritizes a thorough and systematic impact assessment before implementing any changes. This aligns with the principles of robust IT governance and risk management, which are often implicitly or explicitly mandated by regulatory frameworks governing software development and deployment, particularly in regulated industries. Comprehensive impact assessment ensures that all potential ramifications of a proposed change, including effects on other systems, data integrity, security, user experience, and compliance obligations, are understood and mitigated. This proactive approach minimizes the risk of introducing new problems while attempting to fix existing ones, thereby safeguarding the integrity and availability of the application and the business operations it supports. An incorrect approach that bypasses or inadequately performs an impact assessment carries significant regulatory and ethical failures. For instance, implementing a fix without understanding its downstream effects could violate data privacy regulations if it inadvertently exposes or corrupts sensitive information. It could also breach contractual obligations or SLAs if the fix causes unexpected downtime or performance degradation in other integrated services. Ethically, it demonstrates a lack of due diligence and a disregard for the potential harm to users and the organization. Such actions can lead to reputational damage, financial penalties, and legal repercussions. Professionals should employ a decision-making framework that begins with clearly defining the problem and its immediate symptoms. This is followed by a structured impact assessment process, which involves identifying all potentially affected components, systems, and stakeholders. The assessment should consider technical, operational, security, and compliance aspects. Based on the assessment, potential solutions are evaluated for their effectiveness, feasibility, and associated risks. The chosen solution then undergoes a formal change management process, including detailed planning, testing, and rollback procedures. Continuous monitoring post-implementation is crucial to validate the fix and detect any unforeseen issues. Question 13. Research into the integration of a new third-party library for enhanced data processing capabilities within a VMware Spring application reveals that the library is widely adopted and has a good reputation. However, the development team is under significant pressure to meet a tight release deadline, and a formal security and compliance review of the library would add several days to the integration timeline. What is the most professionally responsible course of action? Option A. Integrate the library and schedule a security and compliance review for a later phase, after the application has been released to production. Option B. Integrate the library, but only after obtaining a written assurance from the vendor that it meets all relevant security and compliance standards, without independent verification. Option C. Conduct a thorough security and compliance review of the third-party library, including vulnerability scanning and license verification, before proceeding with integration, even if it impacts the immediate release schedule. Option D. Proceed with the integration immediately, relying on the library's reputation and the vendor's stated security compliance to meet the release deadline. Correct answer is D. Proceed with the integration immediately, relying on the library's reputation and the vendor's stated security compliance to meet the release deadline. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise software development, balancing the need for rapid feature delivery with the imperative to maintain robust security and compliance. The pressure to integrate a third-party library, which is a frequent occurrence in modern development, introduces a significant risk if not properly vetted. The core challenge lies in the potential for introducing vulnerabilities or non-compliance with established security standards, which could have severe repercussions for the organization. Careful judgment is required to assess the risks associated with the library against the business benefits of its integration. Correct approach analysis. The correct approach prioritizes a thorough security and compliance review before integration. This aligns with best professional practices in software development, particularly in regulated environments. It demonstrates a commitment to security by design and proactive risk management. Specifically, this approach adheres to principles of due diligence, ensuring that any third-party component is assessed for potential security flaws, licensing compliance, and alignment with organizational security policies and any relevant industry-specific regulations that might govern data handling or system integrity. This proactive stance minimizes the likelihood of introducing vulnerabilities that could lead to data breaches, regulatory fines, or reputational damage. Incorrect approaches analysis. One incorrect approach involves immediate integration without any vetting. This represents a significant regulatory and ethical failure. It bypasses essential security protocols and due diligence, potentially exposing the organization to known or unknown vulnerabilities. This could violate data protection regulations, e.g., GDPR, CCPA, depending on jurisdiction. Though for this exam we focus on the principles within the VMware Spring context, which implies enterprise standards and internal security policies, leading to severe compliance breaches. Another incorrect approach is to rely solely on the vendor's claims of security without independent verification. While vendor assurances are a starting point, they do not absolve the development team or organization of their responsibility to verify. This approach is professionally negligent as it outsources critical risk assessment, which is a core responsibility of the development and security teams. It fails to account for potential misrepresentations or oversights by the vendor, creating a blind spot for security risks. A third incorrect approach is to defer the security review to a later stage, such as post-deployment. This is a fundamentally flawed strategy. Security and compliance should be integrated into the development lifecycle from the outset. Delaying such reviews significantly increases the cost and complexity of remediation if issues are found, and critically, leaves the system vulnerable during the interim period. This approach demonstrates a lack of foresight and a disregard for the principles of secure software development, potentially leading to immediate or imminent security incidents. Professional reasoning. Professionals should adopt a risk-based approach to third-party component integration. This involves establishing clear criteria for evaluating external libraries, including security scanning, license compliance checks, and alignment with organizational security standards. A formal process for approving and integrating third-party code, involving security and compliance teams, is essential. When faced with pressure to integrate quickly, professionals should clearly articulate the risks associated with bypassing these established procedures and advocate for adherence to best practices, even if it means a slight delay in delivery. The decision-making process should always prioritize the long-term security and compliance posture of the application and the organization over short-term expediency. Question 14. The assessment process reveals that a development team is building a new microservice for a US-based financial institution that will process sensitive customer transaction data. The team is debating the most appropriate security strategy to implement. Which of the following strategies best aligns with U.S. regulatory frameworks for protecting sensitive financial data? Option A. Rely primarily on perimeter security measures like firewalls and intrusion detection systems to protect the microservice from external threats. Option B. Focus on implementing only basic authentication mechanisms and assume that internal network security is sufficient to protect the transaction data. Option C. Implement encryption for data both at rest and in transit, enforce strict role-based access controls, and conduct regular independent security audits of the microservice and its underlying infrastructure. Option D. Prioritize rapid deployment by implementing basic authentication and deferring comprehensive data encryption and authorization controls until after the initial release. The correct answer is C. Implement encryption for data both at rest and in transit, enforce strict role-based access controls, and conduct regular independent security audits of the microservice and its underlying infrastructure. Explanation. The assessment process reveals a scenario where a development team is tasked with building a new microservice for a financial institution. This microservice will handle sensitive customer transaction data. The team is considering different approaches to secure this data, and the challenge lies in selecting an approach that not only meets functional requirements, but also adheres strictly to the regulatory framework governing financial data in the United States, specifically focusing on data protection and privacy, as mandated by relevant U.S. laws and guidelines. The professional challenge is to balance development speed with robust security and compliance, ensuring no regulatory breaches occur. The correct approach represents best professional practice because it prioritizes a defense-in-depth strategy, incorporating security at multiple layers of the application and infrastructure. This aligns with the principle of least privilege and the requirement for robust data protection mechanisms mandated by U.S. financial regulations. Implementing encryption at rest and in transit, along with strict access controls and regular security audits, directly addresses the core tenets of data security and privacy laws applicable to financial institutions in the U.S. This proactive and comprehensive security posture minimizes the risk of data breaches and ensures compliance with regulatory expectations for safeguarding sensitive customer information. An incorrect approach that involves relying solely on network-level security, e.g., firewalls, is professionally unacceptable. This fails to meet regulatory requirements because it does not provide adequate protection for data at rest or in transit within the application itself. If the network perimeter is breached, the sensitive data would be exposed without internal safeguards, violating the spirit and letter of U.S. data protection laws. Another incorrect approach, which is to defer security implementation until after the initial deployment to meet aggressive deadlines, is also professionally unacceptable. This represents a significant regulatory and ethical failure. U.S. financial regulations emphasize proactive security measures and data protection throughout the development lifecycle, not as an afterthought. Post-deployment security patching or retrofitting is often insufficient and carries a high risk of vulnerabilities being exploited, leading to severe compliance penalties and reputational damage. A third incorrect approach, which is to implement basic authentication without considering authorization or data encryption, is professionally unacceptable. This fails to meet the comprehensive security mandates of U.S. financial regulations. Basic authentication alone does not ensure that only authorized personnel can access specific data, or that the data itself is protected from unauthorized viewing or modification, both at rest and in transit. The professional reasoning process for making such decisions should involve a thorough understanding of the applicable U.S. regulatory landscape for financial data. This includes familiarizing oneself with relevant laws and guidelines, such as those enforced by the SEC, FINRA, and state-level data privacy laws. Before commencing development, a risk assessment should be conducted to identify potential threats and vulnerabilities. Security requirements should be integrated into the design phase, not treated as an add-on. Continuous monitoring, regular security testing, and ongoing compliance checks are essential throughout the development and operational lifecycle. Collaboration with legal and compliance teams is crucial to ensure all decisions align with regulatory obligations. Question 15. Risk assessment procedures indicate that a new VMware Spring-based application, designed to handle sensitive customer financial data, has a high potential for security vulnerabilities if not developed with rigorous security practices integrated throughout its lifecycle. The development team is under significant pressure to meet an aggressive release deadline. Which of the following approaches best mitigates the identified risks while adhering to best practices for secure application development? Option A. Prioritize feature development to meet the release deadline, with a plan to address any identified security issues in a subsequent patch release after the initial launch. Option B. Integrate security considerations and practices into every phase of the software development lifecycle, from design and coding to testing and deployment, leveraging Spring security features and secure coding standards. Option C. Implement comprehensive security testing, including static and dynamic analysis, and conduct thorough penetration testing only after all features are developed and integrated, before the final deployment. Option D. Rely solely on the built-in security features of the VMware Spring framework, assuming that their default configurations are sufficient to protect sensitive customer data. The correct answer is C. Implement comprehensive security testing, including static and dynamic analysis, and conduct thorough penetration testing only after all features are developed and integrated, before the final deployment. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise software development, balancing the need for rapid feature delivery with the imperative to maintain robust security and compliance. The pressure to release new functionality quickly can lead development teams to overlook or deprioritize security best practices, especially when dealing with sensitive data. The challenge lies in ensuring that the development lifecycle, from initial design to deployment, incorporates security considerations without becoming an insurmountable bottleneck. This requires a proactive, integrated approach rather than a reactive, after-the-fact security review. Correct approach analysis. The correct approach emphasizes integrating security into the entire software development lifecycle, SDLC, often referred to as DevSecOps. This involves embedding security practices and tools at every stage, from requirements gathering and design to coding, testing, deployment, and operations. For VMware Spring development, this means leveraging Spring security features for authentication and authorization, implementing secure coding practices to prevent common vulnerabilities, like injection attacks, conducting regular security testing, static and dynamic analysis, and ensuring secure configuration of the Spring application and its underlying infrastructure. This proactive integration aligns with the principle of security by design and is a cornerstone of modern compliance frameworks that mandate risk mitigation throughout the development process. It ensures that security is not an afterthought but a fundamental aspect of the application's architecture and implementation, thereby reducing the likelihood of costly breaches and regulatory noncompliance. Incorrect approaches analysis. One incorrect approach involves solely relying on a final penetration test before deployment. This is a reactive measure that identifies vulnerabilities only at the very end of the development cycle. By this stage, fixing critical security flaws can be extremely time-consuming and expensive, potentially delaying or even jeopardizing the release. It fails to address security at the root cause and can lead to significant rework. This approach also increases the risk of vulnerabilities being exploited in production if the penetration test is not comprehensive or if new vulnerabilities are introduced post-test. Another incorrect approach is to delegate all security responsibilities to a separate security team without involving the development team in the process. While a dedicated security team is crucial, security is a shared responsibility. If developers are not educated on secure coding practices and do not understand the security implications of their design choices, they are more likely to introduce vulnerabilities. This siloed approach leads to a lack of ownership and can result in miscommunication and a disconnect between development priorities and security requirements. It also misses opportunities to build security into the application from the ground up by developers who have the deepest understanding of the code. A third incorrect approach is to assume that using a framework like VMware Spring inherently makes the application secure. While Spring and its security modules provide powerful tools and abstractions to build secure applications, they are not a silver bullet. Developers must still understand how to configure and use these tools correctly, implement appropriate access controls, and follow secure coding principles. Over-reliance on the framework without understanding its security mechanisms can lead to misconfigurations and exploitable vulnerabilities. Professional reasoning. Professionals should adopt a risk-based approach, continuously assessing potential security threats and vulnerabilities throughout the development lifecycle. This involves fostering a culture of security awareness and responsibility within the development team. When developing with VMware Spring, this means actively utilizing Spring security for robust authentication and authorization, implementing input validation and output encoding to prevent injection attacks, and regularly scanning code for vulnerabilities using automated tools. Furthermore, understanding the specific compliance requirements relevant to the application's domain, e.g., data privacy regulations, is paramount. Decision-making should prioritize proactive security measures, continuous monitoring, and iterative improvement of security posture over solely reactive fixes. Question 16. Which approach would be most appropriate for securely integrating a new Spring Boot microservice responsible for processing customer financial data with an existing monolithic application, ensuring compliance with data protection regulations? Option A. Encrypt sensitive data only when it is stored in the microservice's database, but allow unencrypted data transfer between the microservice and the monolith over the internal network. Option B. Rely on the existing network firewall to secure communication and grant the microservice broad read/write access to all relevant customer data tables in the monolith to simplify integration. Option C. Implement basic authentication for the microservice and assume that internal network traffic is inherently secure without specific encryption or detailed access controls. Option D. Implement TLS/SSL for all communication between the microservice and the monolith. Enforce role-based access control with the principle of least privilege for data access within the microservice, and establish comprehensive audit logging for all data operations. Correct answer is D. Implement TLS/SSL for all communication between the microservice and the monolith. Enforce role-based access control with the principle of least privilege for data access within the microservice, and establish comprehensive audit logging for all data operations. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise application development, integrating a new microservice that handles sensitive customer data with an existing monolithic application. The core challenge lies in balancing the need for rapid development and feature delivery with the stringent security and data privacy requirements mandated by regulatory frameworks relevant to financial services. Developers must ensure that data in transit and at rest is protected, access controls are robust, and audit trails are maintained, all while adhering to the principles of secure coding and architectural best practices. The potential for data breaches or noncompliance introduces significant financial and reputational risks. Correct approach analysis. The correct approach involves implementing a secure communication channel using industry-standard encryption protocols like TLS/SSL for data in transit, and employing robust encryption mechanisms for data at rest within the microservice. This includes implementing fine-grained access control policies based on the principle of least privilege, ensuring that only authorized components and users can access sensitive data. Furthermore, comprehensive logging and auditing of all data access and modification operations are crucial for compliance and incident response. This approach directly addresses the security and privacy mandates by proactively building security into the integration process, aligning with the principles of secure development lifecycle and data protection regulations. Incorrect approaches analysis. One incorrect approach would be to bypass encryption for data in transit, relying solely on network-level security. This is a significant regulatory and ethical failure because it leaves sensitive customer data vulnerable to interception by unauthorized parties, even within a seemingly secure network. Many data protection regulations explicitly require encryption of sensitive data in transit. Another incorrect approach would be to implement overly broad access controls, granting excessive permissions to the microservice or its interacting components. This violates the principle of least privilege, increasing the attack surface and the potential for unauthorized data access or modification, which is a direct contravention of security best practices and regulatory expectations for data handling. Finally, neglecting to implement comprehensive audit logging for data access would be a failure to provide the necessary transparency and accountability required by many financial regulations, hindering the ability to detect and respond to security incidents effectively. Professional reasoning. Professionals should adopt a risk-based approach to integration, prioritizing security and compliance from the outset. This involves conducting thorough threat modeling, understanding the specific data sensitivity and regulatory requirements, and selecting appropriate security controls. The decision-making process should involve collaboration between development, security, and compliance teams to ensure all aspects are covered. When evaluating integration strategies, always ask, does this approach adequately protect sensitive data according to relevant regulations? And does this approach provide sufficient auditability and accountability? Prioritizing security and compliance is not merely a technical requirement, but a fundamental ethical and professional obligation. Question 17. The review process indicates that a new microservices-based application is being developed, with multiple independent teams responsible for different service components. While the development teams are empowered to iterate quickly, there's a concern that security best practices and compliance requirements might be inconsistently applied across these services. What is the most effective strategy to ensure a robust and compliant security posture for this microservices application? Option A. Establish a centralized security framework with reusable security components, automated security testing integrated into CI/CD pipelines, and clear security guidelines for all development teams. Option B. Allow each development team to independently define and implement their own security measures based on their understanding of best practices. Option C. Implement comprehensive security audits and penetration testing only after all services have been fully developed and are ready for deployment. Option D. Create a dedicated security team that is solely responsible for defining and enforcing all security policies, with minimal direct involvement in the development team's day-to-day activities. The correct answer is A. Establish a centralized security framework with reusable security components, automated security testing integrated into CI/CD pipelines, and clear security guidelines for all development teams. Explanation. Scenario analysis. This scenario presents a common challenge in modern software development, balancing the rapid iteration and flexibility offered by microservices architecture with the need for robust security and compliance. The core tension lies between the autonomy of individual development teams, a hallmark of microservices, and the overarching requirement for consistent security posture and adherence to regulatory standards across the entire application landscape. The pressure to deliver features quickly can lead to shortcuts in security implementation, especially when teams lack specialized security expertise or are unaware of the broader compliance implications. This creates a significant risk of introducing vulnerabilities or non-compliance that could have severe consequences, including data breaches, financial penalties, and reputational damage. Correct approach analysis. The correct approach emphasizes a proactive, centralized security strategy integrated into the microservices development lifecycle. This involves establishing clear security standards, providing reusable security components or libraries, and implementing automated security testing within the CI/CD pipeline. This aligns with best practices for secure software development and regulatory frameworks that mandate a defense-in-depth strategy and continuous monitoring. By embedding security early and consistently, organizations can mitigate risks effectively, ensure compliance, and maintain a strong security posture without unduly hindering development velocity. This approach fosters a culture of shared responsibility for security, where development teams are empowered with the tools and knowledge to build secure services. Incorrect approaches analysis. One incorrect approach involves relying solely on individual development teams to implement their own security measures without centralized guidance or oversight. This leads to inconsistent security implementations, potential gaps in coverage, and a lack of accountability. It fails to address the systemic risks inherent in a distributed architecture and can result in a fragmented and vulnerable security landscape, directly contravening principles of robust security governance and compliance. Another incorrect approach is to implement security checks only at the final deployment stage. This is a reactive and inefficient method that can lead to costly rework and delays if significant security issues are discovered late in the development cycle. It also fails to address the shift-left security principle, which advocates for integrating security considerations from the earliest stages of development. This approach increases the likelihood of vulnerabilities making it into production, thereby increasing the risk of non-compliance and security incidents. A third incorrect approach is to delegate all security responsibilities to a separate, siloed security team that operates independently of the development teams. While a dedicated security team is crucial, this approach creates a bottleneck and can lead to a disconnect between security requirements and the practicalities of development. It fosters an us vs. them mentality and hinders the adoption of security best practices by development teams, ultimately undermining the overall security and compliance efforts. Professional reasoning. Professionals should adopt a risk-based approach, prioritizing security controls based on the sensitivity of data handled and the potential impact of a breach. This involves understanding the specific regulatory requirements applicable to the organization's industry and geographic location. A collaborative model, where security expertise is shared and integrated into the development process, is essential. This includes providing training, establishing clear guidelines, and leveraging automated tools for security testing and compliance monitoring. The goal is to build security into the fabric of the microservices architecture, rather than treating it as an afterthought. Question 18. The analysis reveals that a Spring Boot application is being developed to manage customer financial transaction data, which includes highly sensitive information such as account numbers and transaction amounts. The development team is considering different strategies for protecting this data when it is stored in the application's database. Which of the following approaches best adheres to professional development standards and regulatory expectations for data protection at rest? Option A. Implement a custom-built encryption algorithm developed in-house without external security review to protect the sensitive data. Option B. Rely solely on transport layer security (TLS) to encrypt the data when it is transmitted between the application and the database, assuming data at rest requires no additional protection. Option C. Configure the Spring Boot application to encrypt sensitive fields in the database using a strong, industry-standard encryption algorithm like AES, managed through secure key management practices. Option D. Store all sensitive customer financial transaction data in plain text within the database to ensure easy and fast retrieval for reporting purposes. Correct answer is C. Configure the Spring Boot application to encrypt sensitive fields in the database using a strong, industry-standard encryption algorithm like AES, managed through secure key management practices. Explanation. Scenario analysis. This scenario presents a professional challenge related to the secure and efficient management of sensitive customer data within a Spring Boot application. The core difficulty lies in balancing the need for robust security measures, such as encryption, with the operational requirements of data accessibility for legitimate business processes. A misstep in implementing data protection can lead to significant regulatory penalties, reputational damage, and loss of customer trust. The need for careful judgment arises from selecting the most appropriate and compliant method for handling sensitive data at rest. Correct approach analysis. The correct approach involves leveraging Spring Boot's built-in capabilities and established best practices for data encryption at rest. This typically means configuring the application to utilize a robust encryption mechanism, such as AES, applied to sensitive fields within the database. This aligns with the principle of least privilege and data minimization, ensuring that even if the underlying data store is compromised, the sensitive information remains protected. This approach is professionally sound because it directly addresses regulatory requirements for data protection and privacy, such as those that might be stipulated by data protection authorities within the relevant jurisdiction for this exam. It demonstrates a proactive stance on security, safeguarding customer data, and maintaining compliance. Incorrect approach is analysis. Storing sensitive data in plain text is a critical regulatory and ethical failure. It directly violates data protection principles and exposes customers to severe risks in the event of a data breach. This approach demonstrates a lack of due diligence and a disregard for professional responsibility concerning data security. Implementing custom, ad hoc encryption algorithms without rigorous security review or relying on outdated cryptographic standards is also professionally unacceptable. Such practices often introduce vulnerabilities that attackers can exploit, leading to data compromise. This failure stems from a lack of understanding of modern cryptographic best practices and a disregard for established security protocols, which can result in non-compliance with data protection regulations. Relying solely on network-level encryption without encrypting data at rest is insufficient. While network encryption protects data in transit, it offers no protection if the data store itself is accessed directly or compromised. This approach fails to meet the comprehensive data protection requirements mandated by most regulatory frameworks, leaving sensitive information exposed. Professional reasoning. Professionals should adopt a risk-based approach to data security. This involves identifying sensitive data, understanding the potential impact of its compromise, and implementing appropriate controls. When developing Spring Boot applications, developers should consult the official Spring security documentation and relevant industry best practices for data encryption. They should prioritize solutions that are well-vetted, regularly updated, and align with the specific data protection regulations applicable to their operating jurisdiction. A continuous security assessment and testing process is crucial to ensure that implemented controls remain effective against evolving threats. Question 19. The evaluation methodology shows that when developing a secure VMware Spring application, which approach best integrates security considerations throughout the entire development lifecycle, rather than treating it as a separate phase. Option A. Relying solely on the security measures provided by the underlying cloud infrastructure to protect the Spring application. Option B. Focusing primarily on application functionality and performance, with security being a secondary concern addressed only if specific vulnerabilities are reported post-deployment. Option C. Proactively embedding security best practices, secure coding standards, and regular vulnerability assessments into each phase of the Spring application development process, from design to deployment. Option D. Implementing security controls only after the application has been fully developed and before deployment. The correct answer is D. Implementing security controls only after the application has been fully developed and before deployment. Explanation. The scenario presents a common challenge in professional development, balancing the adoption of new technologies and frameworks with the need for robust security and compliance. In the context of VMware Spring development, this involves understanding how to integrate security best practices from the outset, rather than as an afterthought. The professional challenge lies in identifying and mitigating potential vulnerabilities that could arise from insecure coding practices or misconfigurations within a Spring application, especially when dealing with sensitive data or critical business logic. Careful judgment is required to select development approaches that are both efficient and secure, adhering to established security principles and potentially regulatory requirements. If the application handles regulated data, the correct approach represents best professional practice because it prioritizes security by design. This means proactively embedding security considerations into every stage of the development lifecycle, from initial design and coding to testing and deployment. For VMware Spring development, this translates to utilizing built-in security features of the framework, employing secure coding patterns, and conducting regular security assessments. This proactive stance aligns with the principle of least privilege, defense in depth, and the general expectation of professional developers to produce secure and reliable software. It minimizes the risk of costly and damaging security breaches, protects user data, and maintains the integrity and reputation of the application and the organization. An incorrect approach that neglects security by design, such as only addressing security concerns late in the development cycle, or relying solely on external security tools without internal developer awareness, represents a significant regulatory and ethical failure. This failure stems from a disregard for the potential harm that insecure software can cause, including data breaches, financial loss, and reputational damage. Ethically, developers have a responsibility to produce safe and secure products. From a regulatory perspective, depending on the industry and data handled, there may be specific compliance mandates, e.g., data privacy regulations, that are violated by a lack of due diligence in security. Another incorrect approach, such as assuming that the underlying infrastructure security is sufficient to protect the application, fails to recognize that application-level vulnerabilities can be exploited independently of infrastructure weaknesses. This demonstrates a misunderstanding of the shared responsibility model in security and a failure to implement appropriate application-specific controls. The professional reasoning process for similar situations should involve a continuous cycle of threat modeling, secure coding education, and integrated security testing. Developers should be empowered with knowledge of common vulnerabilities, e.g., OWASP Top 10, and how to prevent them within the Spring framework. Security should be a collaborative effort between development and security teams, with clear communication and shared ownership. When evaluating different development strategies, the primary question should always be, how does this approach impact the security posture of the application? Question 20. Compliance review shows that a critical dependency used in a VMware Spring application has a recently disclosed security vulnerability. The development team is under pressure to release a new feature by the end of the week. The vulnerability is known but has not yet been actively exploited in the wild. The team has identified a potential workaround that would involve modifying application logic to mitigate the risk without updating the dependency. But this workaround is complex and has not been thoroughly tested. Which of the following approaches best aligns with professional development, best practices, and regulatory expectations for secure software development? Option A. Proceed with the release of the new feature using the current vulnerable dependency, assuming the risk is low due to the lack of active exploitation, and document the vulnerability for future reference. Option B. Prioritize updating the vulnerable dependency to a secure version and thoroughly test the application before releasing the new feature, even if it means delaying the release. Option C. Immediately update the dependency to a secure version without extensive testing, prioritizing the release timeline over comprehensive validation of the update's impact. Option D. Deploy the application with the known vulnerability, implementing the complex workaround, and plan to address the dependency update in a subsequent release. The correct answer is B. Prioritize updating the vulnerable dependency to a secure version and thoroughly test the application before releasing the new feature, even if it means delaying the release. Explanation. This scenario presents a professional challenge because it requires a developer to balance the immediate need for feature delivery with the long-term implications of security vulnerabilities within a Spring-based application. The core of the challenge lies in understanding the implications of using outdated dependencies, which can expose the application and its users to known exploits. Careful judgment is required to assess the risk versus reward of deploying code with known security flaws. The correct approach represents best professional practice because it prioritizes security by actively identifying and remediating vulnerabilities before deployment. This aligns with the principle of secure software development, which is implicitly mandated by general IT governance frameworks that emphasize risk management and data protection. By choosing to update dependencies and address security concerns, the developer demonstrates a commitment to building robust and trustworthy applications, thereby protecting the organization and its users from potential breaches and their associated legal and reputational damage. This proactive stance is a cornerstone of professional responsibility in software development. An incorrect approach that involves deploying the application with known vulnerabilities, even with a promise to fix them later, represents a significant regulatory and ethical failure. This demonstrates negligence and a disregard for established security best practices. Such an action could lead to a breach of data protection regulations, e.g., GDPR if applicable to the jurisdiction, though we are strictly adhering to the exam's implied jurisdiction, which focuses on general professional development principles without specific country mandates, unless explicitly stated for the exam itself. Ethically, it betrays the trust placed in the developer to deliver secure software. Another incorrect approach, which is to ignore the vulnerability report entirely and proceed with deployment, is equally problematic. This shows a lack of due diligence and a failure to acknowledge and address known risks. It can be interpreted as a deliberate act of omission, potentially leading to severe consequences if a vulnerability is exploited. This approach directly contravenes the professional obligation to maintain a secure development lifecycle. A further incorrect approach, such as attempting a superficial fix without fully understanding the vulnerability or its implications, is also unacceptable. This demonstrates a lack of technical depth and a failure to conduct thorough testing. It creates a false sense of security and leaves the application susceptible to exploitation. This approach is professionally unsound, as it does not adequately mitigate the identified risk. The professional decision-making process for similar situations should involve a structured risk assessment. This includes 1. Understanding the nature and severity of the vulnerability. 2. Evaluating the potential impact of exploitation on the application, data, and users. 3. Assessing the feasibility and timeline for remediation. 4. Consulting with security teams or subject matter experts if necessary. 5. Prioritizing security updates and patches as part of the regular development and deployment pipeline, rather than as an afterthought. This systematic approach ensures that security is integrated into the development process, leading to more resilient and trustworthy applications.